Hello, pre-calculus kids. We are looking at geometric sequences today. A geometric sequence is a sequence in which the ratio between any two consecutive terms is constant. Basically, instead of like on the arithmetic ones when we were adding and subtracting the same thing each time, this time we're just multiplying. You can think dividing too, but you're really multiplying by a fraction. So if you're multiplying by the same thing each time, then it is a geometric sequence. The common ratio is the ratio that's in common, or the numerical ratio between any two terms, and we use the letter R to represent that common ratio. Just like in the other one we had D for the common difference, then we have R for the common ratio. So let's look at some examples. Determine the common ratio, then find the next three terms. So what's nice is we already know it has a common ratio because they tell us. So to figure it out, there's a couple different ways, but the easiest way is to say the second term over the first term. Or if you recognize it, like you might say, oh, look, here they're multiplying by 3, right? They're saying times 3 each time. Sometimes it's not as easy to see. So if you can't see it, just take the second term divided by the first term and set it as a ratio and simplify it. So here we know R is 3. So then if we need to find the next three terms, next three terms, that'd be 216 times 3. Let's see, that is 648. And then times 3 again, so you get 1944. Times 3 again, 5832. Easy enough. Now on the next one, this is one that may be more difficult for you to see, which we can tell it's going down, right, each time. And it's changing signs, if you notice. So if you don't recognize what they're doing, just take that second term, put it over the first term, and then simplify it, and it ends up being negative 1/4. So R is negative 1/4. So let's see, we're multiplying each one by negative 1/4, or we're dividing by negative 4, if you'd like to think of it that way. This would be 2, negative 1/2, and then a positive 1/8. So anytime you have them as fractions, please leave them as fractions like that and don't put decimals, or at least don't put decimals you have to round off. All right, number 3. This one has decimals. They're getting bigger, but I don't recognize what they're multiplying by because that's it's nothing that goes into it easily. So you can take any of the two terms. I'm going to use these two here and try to figure that out. So it'd be negative 40 over negative 16, and that simplifies to 5/2. So that means my R is 5/2. And since I already know this is a common ratio, it really doesn't matter which ones I choose. But if I didn't know that it was geometric, I would need to probably check multiple ones and make sure that they were consistent. So if I multiply each one of these by 5/2, and this is where your calculator comes in handy, I get 250, negative 625, and negative 1562.5. Now I'm okay with just 0.5, or as long as you're not rounding decimals off. But notice how number 4, we've got fractions already, so I'd want you to leave your answers in fractions. Now this one, any two ones here we can put to figure it out. Let's see, it'd be 9/4 divided by negative 27 over 8. And you could do this by hand if you like, or you can plug this in a calculator. But you get negative 2/3 right there. So R is negative 2/3. And the next few terms would then be negative 3/2, 1, and negative 2/3. Alrighty. Now notice on this next part here, we have the nth term of any geometric sequence can be found using this formula. Okay, so this formula is very similar to the other one with arithmetic. You have a sub n is equal to the first term, but instead of adding d this time, we're multiplying by r n minus 1 times. So that n minus 1 is now an exponent. So at any time if you see a formula and it has an n minus 1 as an exponent or a variable as an exponent, you know it is geometric. So the a sub 1 again is your first term, just like before, and r is your common ratio. So let's look at these examples. We want to write an explicit rule for each of these and then find the 8th term. So notice, oh, I can easily tell they're saying times 4 here. So that means my nth term is found by taking the first term, I'm multiplying by 4 n minus 1 times. So pretty straightforward. So if I want the 8th term, this is 3 times 4, 7 times. And if you plug that in your calculator, you get 49,152. Big number. All right, so the next one, let's see, looks like they're dividing by 2. And remember, if you're dividing by 2, you don't write divide by 2. You actually say times a half, right? So r is 1/2 here. So my nth term can be found by taking our first term, which is 2400, and multiplying it by 1/2 n minus 1 times. So there is our formula, our rule. So if I want to find the 8th term, that's negative 2400 times a half, 7 times. And this one you get negative 18.75. So again, since we didn't round this off, then we can leave it like that as a decimal. That is perfectly okay. All right, let's see. That one's a little bit more complicated on number 6. So I'm going to use these last two terms to figure it out. Negative 42 over 7, well, that's just negative 6. So that means we are multiplying by negative 6 each time. So that's my r. So the nth term can be found by taking the first term, which is that, and I'm multiplying by negative 6 n minus 1 times. So then the 8th term would be 7 over 36 times negative 6 7 times. And yes, you definitely want to use a calculator on this because it gets yuck. Okay, so there's the 8th one. And then, oh wow, let's see, if we divide this out, I can tell they're dividing by something, right? What is that? I'm going to say 800 over the negative 4,000 just to make it faster, smaller numbers, so that's negative 1/5. All right, so that's my r. So a sub n would be the first term. Oops, got my 1 there. Let's make sure I get enough zeros there. Hopefully that's right. It's kind of hard to see, though, those zeros. They start to blur together to me. All right, times negative 1/5, n minus 1 times. And then that means the 8th term would be the first term times negative 1/5 7 times. And I get 1.28. Oh, look, it's positive. Sweet. Awesome. Okay, so number 9, let's see, what are they doing here? Easiest thing to do is just do it on your calculator here. So negative 4,800 divided by negative 6,400. And if I simplify that, it gives us 3/4. Okay, so the nth term is found by taking the first term, which is your negative 6,400, and multiplying it by 3/4 n minus 1 times. So if we want the 8th term, then we just say 6,400 times 3/4 to the 7th power, because that is 7 times. Oh, wow, we get a big number right here. What is that? Negative 54675 divided by 64. So what I did was, because a lot of times the calculator won't give you that, it might give you a decimal, and if you have to round it off, I don't want that. If it's a nice pretty number, actually let me see if it is on this one, because what you can do is you can just do 3 to the 7th times 6,400 and then 4 to the 7th and then simplify that fraction. But sometimes it will actually do it all together. So let me try that right quick and see if it does, see what it gives us. Oh, see, yeah, it gives us a decimal we're going to have to round off, and I don't want you to do that. So what you need to do is do just all the numerators first and all the denominators second, and simplify it as a fraction, and that's what you'll come up with. Okay, so number 10, we're starting with 1/2. Looks like, what are they doing? I'm going to go over to the side and just do negative 3/2 divided by 1/2 to see what that is. Well, the 2's would cancel. So they're just multiplying by negative 3 each time. So that means a sub n is equal to first term times negative 3 n minus 1 times. So if I want the 8th term, it's 1/2 times negative 3 7 times, and you get negative 1093.5. So see, like that one, 0.5 is fine because we didn't have to round it. All right, so this next part is giving us the pieces, and we got to find out what's missing. So if we have the first term, and we have r, and we want the 6th term, well, that's pretty straightforward. I can find the 6th term by taking the first term times r 5 times. So then just use your calculator, and that should give you negative 7680. Okay, so on number 12, the second term is negative 8, r is 4. We need to find the 10th term. Okay, so that means if we have negative 8 is the second term, and we were adding 4, not adding 4, we're multiplying by 4, because this is geometric. So that means we got to divide by 4 to go backwards, right? Because negative 8 is here, and we had to multiply by 4 to get that next term here. So if I divide this by 4, then this would be negative 2. So our first term is negative 2. I mean, that's one way to look at it. Maybe it would be better if I just wrote it in the formula. Maybe I should try that. So the second term would be equal to the first term times 4 one time. So that fourth term, let's say is negative 8, so a would be negative 2, a sub 1. So that's our first term. So the 10th term is taking the first term times 4 9 times. And if you plug that in your calculator, let's see what we get. Negative 2 times 4 to the 9th power. You get negative 52428. All right, so number 13, we have the 5th term. We're looking for the 11th term. So we got to figure out what the first term is first. So the 1/4 would be equal to the first term times 1/2. Oh, how many times? That would have to be 4 times, right, to get to the 5th term. So this would be 1/4 equal to a sub 1. This would be 1/16. So if I multiply both sides by 16, then we get 4 equal to a sub 1. Okay, so first term is 4. So when we go to find the 11th term, we take the first term times 1/2 10 times, plug all this loveliness in your calculator, and you get 1/256. So again, anytime you can leave it as a fraction, leave it as a fraction. All right, number 14. The third term is 4/9. That's equal to the first term times r, which is negative 1/3, twice. So if we simplify this, 4/9, this would be 1/9 times the first term. So if we multiply by 9, so the first term would have to be 4. So when we go to find the 9th term, that means we take the first term times our r 8 times. And on this one, you get a positive 4/6561. And moving along, number 15, a sub 1 is 2, a sub 6 is 486, find the 12th term. Okay, so the 6th term is 486, that's equal to the first term times r 5 times. So divide by 2, that's 243 equal r to the 5th. So to find this out, you've got to take the 5th root of 243, and that's just using your calculator. I can show you how to do that. It's that button that's right above the square root one. You have to put the 5 first, and then the second in the button that has that nth root, and then put in the 243. But you should get 3. R is 3. And if you don't know how to do that, just ask me and I'll show you in class. Okay, so now we want our 12th term. So a sub 12 would be equal to the first term, which is 2, times r, which is 3, 11 times, and plug in all this in our calculator, we should get this big number. All right, number 16, a sub 4 is 75 over 2. A sub 7, we want the second term. Okay, so I need to find, let's see, negative, the seventh term would be equal to, the fourth term times r 3 times, because there's 3 steps between there. So if we solve this equation, this gives us negative 1 over 64 equal to r cubed. Take the cube root of both sides, and you get negative 1/4 is r, which is great because we need that. So let's see. Well, let's see. The fourth term. I can just go backwards, huh? If we're multiplying each time by negative 1/4, can I just divide by negative 4 and just go backwards? Would that be easier to do to find that? Yeah, I'm going to do that. Let's see. I think that might be the easiest method. Okay, so we got term 1, term 2, term 3, term 4. Okay, I know the fourth term is 75 over 2. And going this way, we had to multiply by negative 1/4. So I'm going to divide by negative 1/4, which means I'm multiplying by negative 4. But if you're using your calculator, it makes no difference. You get negative 150, and here you get 600. And this is the answer we're looking for. That's probably easier than trying to solve an equation looking for that. Okay, so let's look at 17 and 18. On these, they want us to write the explicit formula and the recursive formula. So let's see, this is negative 10 over 2, which is negative 5. So they're multiplying by negative 5, that's our r. So explicit one is the easiest, I think. It's taking the first term times the r n minus 1 times. As far as the recursive one goes, the nth term can be found by taking the term in front of it, which is a sub n minus 1, times negative 5, and you have to say the first term is equal to whatever that happens to be. Now sometimes instead of seeing that negative 5 at the back, a lot of times in the textbook it may be written like this, where if it's just multiplied by something, it's in front of the a sub n minus 1. But they both mean the same thing. On number 18, let's see, this would be negative 2/3 over negative 4/3. So this would give me 2/4, which is 1/2. Okay, so r is 1/2. So explicitly, a sub n would be equal to the first term times r n minus 1 times. Recursive, a sub n is equal to, and if we want to say, the term in front of it times 1/2, and we have to specify that the first one is negative 4/3. Or we could say it as 1/2 times a sub n minus 1. Either one is fine. Okay, so now for the last page. This looks at the geometric means, very much like the arithmetic means, where it's the terms between any two non-consecutive terms in the geometric sequence. So if you're given this particular sequence, the geometric means between 3 and 243 would be 9, 27, and 81. That's the 3 numbers in between them. So on the examples, number 19, they're asking us to find 3 means in between those two. So I have negative 4, and then I've got 3 blanks, and then negative 2500. So what we have to do is figure out what is r, basically. So I know this negative 2500 would be equal to the first term times r 4 times, because there's 4 steps there. So if I solve this equation and find out what r is, then that'll tell me what I need to know. Fourth root of 625 is 5. So then our numbers would be negative 20, negative 100, and negative 500, because they're multiplying by 5 each time. All right, only one. Sweet. Okay, so 2, and then there's a blank, and then there's 9/8. So we know 9/8 would be equal to 2 times r twice. So if we solve this equation, let's see, divide by 2, take the square root, that's 3/4. Alrighty, so that means I'm multiplying by 3/4, so that would just be 3/2 would be the missing piece. Alright, so the next one, oh dear, I wrote on it, you can't hardly see it. Okay, so 243, and then there's 2 means, and the next one is -72. Okay, so -72 would be equal to the first term times r 1, 2, 3 times. So if I solve this, let's see, that's -8/27. Again, don't leave that as a fraction because then you won't recognize that those are perfect cubes. If I take the cube root, I get -2/3 is equal to r. So we're multiplying each one of those by -2/3, so I get -162, and 108 is my 2 missing terms there. Then on number 22, let's see, 4 means, so -960, 1, 2, 3, 4, and then 15/16. So that means the 15/16 is equal to our first term times r 1, 2, 3, 4, 5 times. Solving for that, let's see, dividing by that would give me, in a simplest form, -1/1024 equal to r to the 5th. So if we take the 5th root of that, you get -1/4. So that means my next numbers in the series would be, the sequence would be 240, -60, 15, -15/4. All right, all we've got left is a couple of application problems here. So in 2009, Eva purchased a new truck for $45,000. Each year, the value of the truck depreciates at a rate of 18%. Use a geometric sequence formula to find the value of Eva's truck in 2017. All right. Okay, so originally it's $45,000 for the truck. And if it's decreasing at a rate of 18%, then let's see, 100% minus 18, that's 82. So 0.82 is what it's keeping each year. And how many years is that? 17. That's 8 years. So if you multiply that out, I think you get 9198.63. So that's how much it should be worth in 2017. And then 24, Garrett signed a new cell phone contract in 2014. Table to the left shows the average monthly bill in those 3 years. If this pattern continues, use a geometric sequence formula to find his average monthly bill in 2025. Okay, so what are they multiplying by each time? Well, to find out, let's see, you have to say 7650 divided by 75. Well, that's 1.02. Okay, so it's going up by that. So, first term is 75. And 1.02 is what it's going up by. How many years is that? 2014, and we want 2025. So 25 minus 14, that's 11. Oops, 11. So it's the 11th. Okay, so that should give us 93.25. Alrighty, we are done.